Hello guys, today I'm going to explain you the concept of double linked list. So single linked list will always travel in one direction. There is no traversing back concept, but there are lots of disadvantage of that concept, and due to that we need double linked list. In double linked list we can traverse backward, we can traverse forward also. That's the advantage. So for that what we require a self-referential structure and understanding of pointers. So what today I'm going to explain you is how to add a nodes at the beginning in a double linked list. So I'm going to create a double linked list, and each and every time I'm going to add all the nodes at the beginning. So if I'm creating new node, it should be added at the first, at the beginning. So for that I'm going to use a student structure. The student structure will only have one data members, and data member is, let's say, ID, and then it will have two pointers, self-referential pointers, which self-referential structure pointer, it means that next and previous. So I can traverse previous also, and I can traverse backward also. So let's get started. So first, in next videos what I'm going to do is, so this is a basically menu driven program. In that I'm going to make a function like add at beginning, which will add the nodes at the beginning. Then in next what I'm going to do is I'll make add at the last, add at the middle, add at the position that's supplied by the user, add one node to another node position, then delete the node, delete at the middle, delete at the last, delete at the beginning, delete at the position given by the programmer or user, or search a node specific, search by ID, because we are just going to use ID. You can add search by name, search by roll, search by marks, highest marks. You can add any data members or extra variables inside the structures. It's totally depend on you, but this is a basic representation. That's why I'm just going to explain you with the roll number. So for that I need a menu, so I'll say menu.c. Okay, so first what I need to do is I need to add all the required header files. So good habit or method is to create a header file .h and add each and every header files in this file. So I'm going to add like standard stdio stdio.h. Then sometimes if I need a library, so I say stdlib.h. Sometimes I'm going to use some string functions, so I'm going to add it also here. And in my what I'm going to do is I'm going to use make utility. So it is a very good practice to use a make utility to put each and every function of your program in separate files and then combine all of them and make a one executable file. So for that I need to add structure declaration in each and every file. So I don't need to do that or don't need to write in each and every file. Because of that I'm going to edit my header file. So I just add the header file, and if I add header file in each and every file, automatically it's going to put my structure there. So I'll say structure struct student, then I'll say integer ID. So this is ID, and I need two pointer, one say next, one say previous. So this is my structure, a very basic structure. Okay, so I created it. Now I'm going to make my linked list. So first let me go to the menu.c again. I'm going to edit here. So headers storage. Okay, now I'm going to start my main program from here. Okay, so what do I need? I need I need to make a head pointer and a last pointer. So if you are familiar with the double linked list concept, you will know that in double linked list we have two pointers. One pointer is always pointing to head, means first node, and another pointer will always pointing to last node. So that if we want to traverse from last to first, we can use last function, last pointer help, and we can traverse backward to forward, so it's easiness. If we want to traverse from beginning to the end, we can take help of head or first pointer. That's why I'll create two pointer in here. One I'll say head. Head will means always pointing to first head node, and then last. Last will always points to last node. Okay, so as I'm going to make an menu driven program, because of that I'm going to create a while one, so it will constantly display the menu, so I can choose the options from there. For that I need choice, so I'll say choice, and then I'll say okay, printref. First I'm going to do add at the beginning, so add begin. So whenever I say that, it will add at the beginning. Okay, so I'll say okay. So here I'm going to add lots of other functions like add at last, add at middle, add at the position. So that's why I'm going to say here enter the choice. Right now it's only one choice, but later it's going to be lots of choice, so I have to ask the user that choice one choice from the above option. So I'll say choice. Okay, this is my while loop. Now I'll use switch case, because as the user enter the choice, from that choice I need to identify. If my case is 1, it means user has chosen 1 at the beginning. So what I'm going to do is I'll just call. Okay, so one problem of double linked list is if you are familiar with the single linked list, what we can do is we can return our head pointer or PTR. If we modify some linked list, or let's say there is only one node is available, and that node we're just going to delete the node. So when we delete that node, our link is empty, but our PTR is still holding that node address. So for that, if I'm using a separate function for that linked list, what I need to do is I have to return that PTR value as null. So I have to reset that PTR as a null, right? But here the problem is my head and my last two pointers are there, and both of the pointers is at the first pointing to my head, means first node. So if there is only one node and if I delete it, so what I need to do is I have to return two pointers to modify it. So I have to return like okay, return head also, return last also, and both should be null. So it's not possible to return two value at once in the function, and because of that reason I'm going to use a double pointer, so that directly whatever modification I do in that function, it directly reflect in here, so I don't need to return anything. So that's why what I'm going to do is I'll say add begin. This is my function that I'm going to create. I'll say address of head and address of last. So as I'm passing the address of pointer, it should be collected in double pointer. So let's make the function. Okay, so I'll make add begin. Let's see. So I just need to add the header files that we have created, address to edge, and then I don't need to return anything because I'm just passing the reference of my head and last. So whatever modification I do in head last in here, we're directly going to reflect in my menu program. So I'll say add begin, and I should collect it structure student in double pointer. So I'll say my PTR means my first pointer, and I'll say LPTR my last pointer. So now I have collected my head in PTR and my last in LPTR. Now I have to add it. So what I can do is to add a node, first node should be exist. due to that I need to create one node in here. So for that I'll take a new. Okay, I'm just going to use calloc to allocate dynamically one node size of structure. Okay, so memory is allocated. Now let's initialize the memory. Here structure is represented as node, so I'll say enter the role or ID. Let's say enter the ID and just say scanf. Let me scan that ID. So new points to that ID. So now I'll get the ID. Let's say ID is 1. So when I write 1 is so 1 value with the ID and my next and previous pointer, which are member of my structure student. Right now they all are 0, means null, because I'm using calloc, so all the memory block has the value by default 0. So as this my first node, what I need to do is I need to add it to my head node, and my last node is my first node. So here last node and first node both are same. So what I'm going to do is, if my LPTR, my last node, is equal to null. So yeah, it's null because there is no a node, there is no a linked list exists before this, so it's null always. So what I need to do is, let's make it my new. So my new node is added. So my last pointer is pointing to first node, and in this link my first node is my last node, both are same. So but if there is a link is exists already, let's say there is a one node is already exists, so what I need to do is my head should point into that node, always first node, and my last node should point into second node, because second node is right now last node if I add a new node. But is this function is adding at the last? No, it's adding at the first. So what I want to do is, I'll say PTR. So why I'm writing right now PTR is null, but why I'm writing this, I'll explain you. Just wait. So see, it's a previous, and I'm saying it's new. Why I'm writing this, I'll explain you, because this algorithm will explain better if you wait. Okay, then next is equal to okay. Now you can understand what I did there. Okay, so what I actually am doing is, as this my first node, right now I'm adding only one node in here. Because of that, what will happen, my last node and my head node both should be pointing to first node. Yeah, that should be the condition. So first I'm checking, is my last node equal to 0, null? Yes, it is. Then add my new node, first node, to my last node. So I done it, right? So else pass will not execute. But what I need to do is, I need to assign this newly created first node address to my head node also, because at the starting, when there is only one node, head and last both should be pointing to first node. So this else will be just not going to execute. Then here new points to next is my new node that I just created, points to next, means it's a next address, is equal to star PTR. As my star PTR is null, the next will be null, so no difference. One node, there is no node just after it, there is no node before it, it's only one node. So what I need to do is, I need to add my this new node to my head, because at the starting, head means PTR, last means LPTR, both should be pointing to first node. So then I modify it. So my first node is created right now. Now what I'm going to do, I'm going to add second node, but the second node should be added at the beginning. So what I need to do, I have to push my first node that just I created just to second position, so that my first position can be occupied by my newly created node. So when I'm going to create a new node, when I'm going to call this function again, what will happen, it will create a new node for me. Let's say it allocate it says ID is 2, so my 2id. Remember that this first node is already exists, and now I'm going to add second node at the beginning. So my first node id was 1, and my second node this I'm just created, it id is 2. So is my LPTR null? No, it's not null because it's pointing to first node. So I'll say okay, go to the next else part. So here is star PTR means my head is pointing to my first node. My first node previous should be my new node. Yeah, this is the case, because what will happen, I'm adding at the beginning. It means that my first node's previous should be my newly created node, and my newly created next should be my first node that this I created before. So because of that, this condition is required. So what I'm going to do is star PTR's previous should be my newly created node. So this is how we add at the beginning. So my new is add at the beginning, and my new's next will be my old node, old first node. So it will add that my first previous will equal to new. Then new's next is equal to star PTR. Star PTR is my ID number 1 node. So my ID number 1 node is added the next of my newly created node. Newly created node ID is 2, and then I'm just updating. My head is equal to new. So head should be always pointing to first node, and so that's why we have to give our second ID number 2 to our head. So now our head is pointing to ID number 2, and ID number 2 next is my ID number 1. It's created. And if you can notice in here something, that this condition will execute only once when I'm creating a new node, because when I'm adding new node at the beginning, my first node that I've created will always move backward, will move position second, position third, position fourth. It always pushing, moving aside. So my last node will always pointing to my first created node. Doesn't matter if I had 1,000 nodes or 1 lakh node, my last pointer will always pointing to my first created node, right? This is the condition. Okay, so now what I'm going to do is, so this is the add at the beginning. Okay, so in my menu, if I see if I made some differences or not. Okay, no differences there, so we are good. Okay, what I need to do is I have to tell compiler that don't bother about this beginning, because its definition will be found in other file. So I'll say begin. I'll say it's a structure type argument with student type. It's a double pointer. Then it's a structure student double pointer. Done. Okay, so this is it. Now I'm just going to compile it, and we're going to run it, and we'll see if it's going to edit or not. But before that, what we require a print statement so that we can see. So I'll guess 2, we'll say display, and to display, it doesn't matter if we display from the end to beginning or beginning to end, because we're going to display. So let's display it from beginning to end. So we are going to pass our head here, right? And as we're not going to modify any changes, if you don't pass this head address also, it will work. So just let it be like that. Okay, so for that I need to make a display function. Why I'm creating a separate file? Because I want to use make utility. Right now there is only one function, or I'm making a second one. So display structure student star PTR, and what I need to display is, so I'll start from the while PTR, and I'll say printf ID %d PTR points to next. Oops. ptr points to id, then here ptr is equal to ptr points to next. So it travels from starting to end. I will print each and every id one by one. So that's a small display function which will display our IDs, right? So this is our display. So what I'm going to do is, now I'll add it declaration at the top. So I'll say void display structure of student. That's it. Now let's compile it with GCC. So GCC menu.c, add at the beginning display. Okay, so it's a compile and it has created arrow out. So it's a arrow out. Okay. Oh, I forget to mention display in my printf. So I just add it here. So I'll say 2 dot display and then end. So now I'm going to run it again like this. I'm going to do this. Okay. So of course, if I just right now put 2, will not display anything because there is no link. Linked list exists. But if I want to create a linked list, I say 1. I'll say id 1. So 1 is added. And again I'll call 1. I'll say 2, then 1, then say 3, 1, then say 4, and then say display. So as you can see here, it has displayed 4, 3, 2, 1. So first node is added, then second node is added at the beginning, and then again third node is added at the beginning, and fourth node is added beginning. So this is how you can add each and every node at the beginning. Thank you.